All right, let's check how you did with your synthetic division.
Oh, because there's an extra 2.
Okay, check it out. And did you see that 2 of them didn't have remainders? Which means, and you might have looked at the first one, this is a regular quadratic equation, which you know how to factor. What we did after our synthetic division is we factored it perfectly. It had no remainder. The second one had a remainder of 4, so this one isn't factored perfectly. But the last one is factored nicely, and we've started to factor. So a pattern that we're going to notice, and I'm going to color code this, is that if you plug in 1 into this equation, it's the same as plugging 1 into the factored form. Does that make sense? That if g of 1 means I put a 1 in for x. I could do it this way. 3 times 1 squared minus 2 times 1 minus 1. And I get 0. I could also find g of 1 by plugging it in the factored form. And something beautiful happens when I plug it in the factored form. Watch. Mental math-wise, why is this beautiful? This is 0. Doesn't that make your life easy? Right? Because, I'm always impressed with students' 0 times table. I'm like, how far have you got your 0 times table up? They're like, I've worked it up to like over 1,000 already. I'm gonna work on the 10,000s next week. Right? Our 0 times table is amazing. Same thing here. What happens when I'm gonna plug in f of 3? This would be annoying to plug in 3, would it not be? Like you'd have to 3 cubed, 27 times 3. Oh my goodness, big numbers. But how nice is it to plug in? I'm not even going to write out the next part. Because what's 3 minus 3? 0. And I would have 0 times all of this, which is 0 plus 4. Does it make sense that that answer is going to be 4? And the last one, can someone, without having to write down or do any mental math, tell me what h of negative 2 is going to be? 0. And this is something that is called the remainder theorem, and a branch of it, the factor theorem. So if you've written your division statement, it becomes really obvious that if you plug in the number that makes this 0, in other words, the opposite of whatever the sign is, you always get your remainders. No matter what you plug in, you get your remainders. And this is on, if we turn to the next page, this is called the remainder theorem. So it says when a polynomial is divided by x minus a, if you plug in a into your polynomial, you always get your remainder. So this is the way that in mathematics we would say it in general, but we have seen it now with a specific, and when you see it with a specific, then the general makes sense. Sometimes if you just see the general rule first, you're confused. You have to see it with a specific example to see it. And this will always happen. So when we get to example 1 here, it says determine the remainder when each thing is divided by each binomial. And you have 2 options. So when doing these questions, you have 2 options. Option 1, you could just plug in, I'm going to go let p of x equals, to save myself some time, you could just plug in 3 and see what the answer is that you get. Or option 2, you could actually do your synthetic division. That'll be 2, -5, -5, 5, 3. And we're dividing by x minus 3, so there would be a 3 out in front. So we're going to look at both options and decide, sometimes one option is better than the other. We're going to have a look at which option we like. Okay? If you were plugging in 3, this would mean each x gets replaced with a 3. So I'm just replacing all of the x's with 3's. And now I have some mental math to do. 3 to the 4, 81 times 2, 162. 3 cubed, 27 times 5 minus 135. 3 squared, 9 minus 5 minus 45. 5 times 3, 15 plus 3. Did I do all the mental math correct? Okay, and now we have to put this together. Is it 0? Does it work out perfectly? Minus 30 minus 165, I'd be at minus 3 plus 3. I think it's 0. Okay? Let's look at the synthetic division option. What would we have to do? We'd have to bring down the 2. 3 times 2 is 6, add. 3 times 1 is 3, add. 3 times negative 2, negative 6, add. 3 times negative 1, negative 3, add. There's my remainder this way. Which option in this example is better, in your opinion? Option. This is like, that was a very emphatic opinion. Yes, I think I agree. Option 2 was way better in this situation for mental math purposes, right? What was the hardest mental math we had to do here? Well, you had to do like 27 times 5, 3 to the 4 is 81. We had some big numbers to work with. What is the hardest mental math we had to do on this side? 3 times 2? That was pretty intense to get that 6. How about negative 5 plus 3? Integers. That was pretty intense. So I find that option 2, the synthetic division, with bigger numbers, and by bigger numbers, usually I'm talking about numbers bigger than 1. Usually bigger numbers, you're like, oh, I'm like, tell me a big number, you'd be like 3. You'd be like, wait a minute, that's not that big. But in this situation, 3 ended up being really big when you have powers, right? 2 is going to be the same thing. I would probably choose option 2 for x plus 2 as well. However, there will be some questions that option 1 is still the better option. Okay, I'm going to skip example 2 so that we can do things a little bit quicker. And I'm going to get you to circle 4a, 6a, 7, and 8. If you want to see part B, it would be on a video that I've done in the past.